Okay. So, there is a state of art statistical model. If you see, this is the block diagram of a state of art statistical model. So, in here what we want in speech recognition, the problem in ASR is that whatever the spoken, I can say the set of sentences that can be generated, that or I can say that I have spoken a sentence. This is the acoustic signal which is measured is A. So, what I am saying, there is an acoustic signal which has framed and parameter are extracted, and that measurement is called acoustical measurement. Okay. So, I said I have recorded that acoustical signal, I extracted the parameter as I discussed frame wise, either 100 frame per second or 50 frame per second as you wish. Okay. Now, that is called acoustical measurement. Then what is ASR? That from the acoustical measurement I have to predict which word I have spoken. Understand? So, there is a given acoustical model, I have to find out which word I have spoken. So, I can say the problem is probability of W for a given acoustical measurement. So, I want maximize the probability of recognize the word, correct word for a given acoustical measurement. So, if I say that this this ASR is designed for this set of word W1, W2, W3, W4, W5 like that, then I can say okay, for a given acoustical word, acoustical measurement, what is the probability of any word of this given list. Okay. Now, Bayes theory I can apply. This can be equal to probability of A given a W into probability of W divided by probability of A, joint probability. Okay. So, if I want to maximize this probability, this can be treated same problem. I can state that I have to maximize this one. Now, probability of A, probability of acoustical measurement, all the time I am taking the acoustical measurement. So, I can ignore this is not required, because I have all equal, the acoustical measurement is there. I am not saying I have not measured the acoustical measurement will be not there, but I have to given that I have to recognize the word. So, probability A of A I can omit, this always let us say 1. Now, the maximization problem boil down to the maximize the probability of A for a given W and probability of W. So, what is the meaning? I have said that for a given acoustical measurement, find out the maximum probability which is the A is belong to which word, or which word, if which word give me the maximize this probability, so max of this one. So, this acoustical measurement are maximally mapped to which word or maximum map to which word. Okay. That converted to for a given set of word. Now, the word is given for a given set of word, I have to maximize this acoustical observation. So, probability of this acoustical measurement is maximum for which word, okay, and multiply by probability of W. So, this is acoustical measurement. So, this is called acoustical model and this is called language model. So, this is the statistical model in ASR. So, developed an acoustical model. So, what I have to do that I have a given that W1, W2 is there. So, I said whatever I have measured in acoustical measurement A, whatever the parameter I have extracted, find out the maximum probability of A for a given W1, W2, W3 or Wn, which is for a probability of A for a given W. So, argmax of probability of A for a given W and probability of W. So, I have to maximize this one and maximize this one, or I can say the product has to be maximized. This is called language model, this is called acoustical model. So, acoustical model is done based on the HMM and language model done based on the trigram, bigram, trigram or unigram model. So, this is language model, bigram, trigram and this is HMM model for acoustical signal. Okay. I have not details discussed how this HMM model is done. So, this is nothing but a maximization of the probability. Okay. Now, I come to the issues. What are the issue is there? Now, first issue is the speaker model is to, okay, forget about these slides. Now, this issue. So, what I said that acoustic signal is related to set of W. So, what I said that if I do that way, that word source or W is there, speaker has spoken that word, production of that word, from the production signal I measure the acoustic parameter, from the acoustic parameter I want to detect this W. So, I am estimating this W. Okay. So, this is ASR system. Now, I have to say I am assuming the acoustical signal is related to written text W. That means, I am assuming W cap is estimated output of the word written language. The input word must also be message in written language. So, suppose I am speaking some sentence. That means, if I speak spontaneously, so how the when a speaker said some sentence, how they generate that message? There is a message planning, idea, message planning, production. Now, my ASR model told me that whatever the production signal is there, that is nothing but a W1, W2, W3, W or whatever the some set of words, which can be explicitly expressed in written form. But there is a catch. Spoken word and written word are not identical. When we listen the words, we can identify spoken. So I am saying that speaker, when it produces the speech, I have prompted the speaker that you have to set this W1, W2, W3, W4, Wn. Okay. So, that means something which I am reading, text is given, speaker is read out the text. For that signal, this ASR model is valid. Now, if I say it is a spontaneous speech, I am speaking. When I speak, I do not care about what is written in there. Some words omitted, many things. You record it, record any, just continuously read, even if continuously read one paragraph, not that first time reading. If you practice 10 times, then read it, then you find many cases, many syllables, many words are dropped. Or I can say, when human beings communicate, we never say complete message word by word, or even if in continuous speech all words are not explicitly mentioned. If you find in continuous speech, always end of the sentence the amplitude is going down. Even I have seen many cases in end syllable is not there, acoustic signal is not there. So, this ASR model does not model the speaker mind. What, or you can say what speaker want to say, that is prompted by the input text only. But if it is not prompted, all kinds of variation of spoken language will be there, and my model is not true for that. So, this is the challenge. Details I will discuss. Next challenge is the understanding the input message. But what speaker does? He understands the input message and then spoken. So, whatever the speech production output is there, it is not W, it is a spoken, or it is a spoken, and whatever I estimated, I want to estimate this W only. But acoustic signal is only contain the spoken information, not written information. How they are different, I will come. So, similarly, there is a problem in language model also. What I said, that language model I have PW is nothing but a language model which can be developed by bigram or trigram probability. What is bigram probability? Bigram model, that for a PW, P given W2. So, if I have a sentence W1, W2, W3, W4, I can say the bigram model is PW1, PW2 for a given W1, probability of W3 for a given W2, then probability of W4 for a given W3, like that way. That is bigram model. Similarly, trigram model, probability of W1, W2, then W3 for a given W1 and W2. But up to trigram model I can go. If I go beyond above trigram model, the complexity will be arised. The required training data size will be very huge. So, even if develop the trigram model also, the required training data size required very huge. So, for a less resource language, whose computerized resource are very less, those languages, development of trigram model and acoustic models is very difficult. So, this statistical problem, it is true that statistical means if I have enough data, then my statistical inference may be very good. If I have a limited data, then I have a statistical inference is very limited. So, statistical model, the limitations are, it does not make distinction between the spoken language and written language, what I have described. That we have defined the ASR for a given W, but it not distinguishing between the written language and spoken language. If the noisy communication channel model does not approximate the situation involved in ambiguity, that I will discuss later on. Ambiguity means there is some ambiguity in written language by ice cream. I do not know whether it is ice cream or ice cream. Okay. Then it is impossible to use higher order statistical model for language model. Beyond trigram I cannot use, but that trigram model not give me the enough language model information. So, what should I do? So, there is till there is an open challenge is called spoken language recognition. So, I have to develop some system which is spoken language recognition. Spoken language is differ from written language. Speech in text or physical signal. So, Fujisaki, if you see the slide is taken from the Fujisaki, Hiroya Fujisaki. He said that spoken language versus written language, spoken new concept in spoken language, speech and text are physical signal, but also serve the different code system. The information they carry are not identical. Spoken language refer to both signal and code system, same applies to written language. Now, if you discuss difference in ambiguity, so there may be something is difference, spoken language is ambiguous, but written language is not, but something in written language is ambiguous, but spoken language it is not. That is homomorphism and homonymity. ambiguous in spoken language, but not in written language. Flower, flower, both pronunciation are same, but their spelling are different. Written language they are not same. Similarly, written language they are same, but pronunciation, but written ambiguous in written language, but not in spoken language. Close, interest. Okay. Now, if I come the prosody, this is the important issue. Spoken language not only contain the words, linguistic information. So, I said linguistic information or not, words is not only the linguistic information. There is a linguistic information called prosody. So, prosody is message, how the message is planned, rhythm is important. So, I said the spoken written language word boundary are not exist in spoken form, but there is a boundary in spoken language which is spoken language boundary, not written language boundary. If I say in English, there is a two example, old man and woman. If I say the old man and woman, then man and woman both are old. If I say the old man and woman, then man is old, but woman is not. Similarly, in Bengali, I give an interesting example. Porashona korona porle shikhbe na. If I say porashona korona porle shikhbe na, I can say like that way, or I can say porashona koro na porle shikhbe na. If I said that, the meaning is different, and if you see the word boundary positions, the position of the boundary are different. Porashona koro is same, na porle shikhbe na. Porashona korona porle shikhbe na. So, prosody ambiguity is there, but the prosody information is very important. Now, so spoken words identification is very important. Word boundary marking, word language, the spoken word, written language, or ice cream, ice cream. If I say ice cream and ice cream, spoken language ambiguity. Then I am not going details of the written language and spoken language. So, then we have in our team are doing some research on spoken word or prosodic word based continuous speech recognition system. We said the written language words are different from spoken language word. So, instead of training the same system with written language, can I train the system with prosodic word or spoken word language, spoken word. So, we developed a system which trained on spoken word for Bengali. Okay. Now, identification of the spoken word is important. So, spoken word is identified from a spoken language database. So, I can say I collect the spontaneous speech and identify the prosodic information based spoken word position, and I said those words I can create a dictionary, and I told the recognizer those are the spoken word, not W. So, I can say dictionary, so I can say that my statistical model only estimate S cap from S, not W to W cap, because W is converted to S. So, I am saying my thing is that I have a S, I estimate S cap and then try to convert with W using language model. Okay. So, if you see that there is a lot of research in this area, this is the proposed model that prosodic word or boundary are identified. There is a lot of one thesis is there. My own research is also in this direction. Then manner based labeling, pseudo or formation, and then if you want the details, then you can contact me. I can share you the all details information of this. I am not detail discuss this kind of things. This is available. Okay. So, this is complete of speech recognition, speech technology or speech recognition things. Okay. So, next class let us discuss about something on speech based e-learning or my dream research action conversion. Okay. So, next class maybe 10 to 20 minutes we try to discuss in the next class. Okay. Thank you.